Now let's go to solve this problem. It's say an airplane needs to reach a velocity of 203. So this is the airplane, now the velocity is 0. He said that he performed 2,000 meters, and when he's here, the airplane is here now with velocity 0. Now the airplane must have velocity v equal 203 kilometers per hour. 203 kilometers per hour. If he doesn't have this amount of velocity, he cannot take off. So he needs this amount. So it means that there is acceleration here because he starts with initial velocity 0. So the plane is here with initial velocity and it has to end on 203 kilometers per hour after running for 2,000 meters. So we will use the equation with constant acceleration. The equation for constant acceleration is xt equal x0, that I didn't write here because I suppose that the x0 is 0 because he will start here, plus v0t plus 1/2 at squared. And the velocity v of t equals v0 plus at. If you work with this equation by solving for t here, you solve for t and you put it inside here, you will find this equation. V squared equals v0 squared plus 2 times a by delta x. So we will use this equation. Instead of using these two equations, we will use this equation that is a combination of the two equations. Try to do it. Solve for t on this equation, on the second one. Put it here, and you will find that the x, or the delta x if you want, because this is x minus x0 is the delta x. X minus x0 because I have put x0 equals 0. So you will see that you will obtain this equation. So let's go to do the problem. B final square have to be 203 kilometers per hour. 203 kilometers per hour square. It's good if you pass the 203 kilometers per hour square to meters per second, but it's not as good. It's that you need it unless you express the 2,000 meters in kilometers, and when you put the displacement, you put 2 kilometers. Remember what we talk about consistency in the equation. So let's go to the consistency. So equal 0 squared. Oh, we are lucky because we didn't express the kilometers per hour, 0 kilometers per hour. 0 squared is 0. Okay, 2 times. The a is the unknown. And the delta x is 2 kilometers. Okay, now the a will be 203 kilometers per hour square divided by 4. 2 by 2 is 4. So the acceleration will be in 4 kilometers. This is 2 by 2 kilometers. This is the 2 kilometers, it's 4 kilometers. So the acceleration will be an amount that is 203 squared, I don't know, divided by 4, I don't know, but you will see that the acceleration is kilometers. It will appear kilometers square here, that will cancel with this kilometers per hour square. So this result is in kilometers per hour square. Now they don't say kilometers per hour here as the result, as the possible option. So you need to convert these units, whatever is 203, to meters per second square. Or you need to start the problem by saying that the v is 203 kilometers per hour, or 203 multiply 1 kilometers. 203 by 1 is 203 kilometers divided by 1. 1 hour is 1 hour. So it's 203 by 1,000 divided by 3,600. So you make here and you find the velocity in meters per second. Now you can use this equation with this data. V final is this one, and delta x is in meters, and you are fine. So you have two procedures to do it. The first procedure, you don't convert the units, but at the end you will find a number that is kilometers per hour square, and you need to convert it to meters per second square. This is the first procedure. Then the second procedure is starting with the correct units in meter per second. You find the meter per second. You use this equation. So do it and find which one is the correct answer. It's just a manipulate. It's just practicing how convert it to units. Go to the next problem. Okay, this problem is a little bit. Complicated. Initially, there is one car and the track. The motion of the car is motion with constant acceleration, so it's not a rectilinear line. The motion on x as a function of time is a parabola. And later on, when he arrived to certain time t, the motion is a constant velocity. So I prefer that you see the problem what I have done. Try to think what I have done here. Try to think what I have done and see if you can do it. Okay? What I have done is not very complicated, but it has a lot of details. So this problem says a ball is projected upward at time t equals 0 from a point of the roof at 90 meters above the ground. The ball rises, then falls, and strikes the ground. The initial velocity of the ball is 80.5. So the ball is launched for 90 meters with the initial velocity 80. Consider a quantity as positive in the upward direction. The velocity of the ball is 89 meters above the ground when the velocity is 89 meters per second. When the velocity is 89, when the velocity of the ball, when the position is 89 meters, when he's here, 1 meter below the initial position, when he was launched at 90 meters, he's go up and going downward. When he goes downward and is passed with the 89 meters, with 89 meter position, what is this velocity? Well, the easy way to do it is using this equation, v squared, the velocity square of v0 squared plus 2 times a by delta y. So in this case, the initial velocity is 80.5, the 2 is the 2, the a is minus 2, and the displacement delta y is minus 1, because it goes from 90 meters to 89, the displacement delta y, y final, minus y initial, 89 minus 90 is minus 1. This will allow you to find the velocity v. But the second way is the way that you need to use to find the velocity, and is the following way. First of all, write the equation of motion. What is the equation of motion? This is a motion with constant acceleration. So the equation of motion is the equation for a constant acceleration, y0 plus v0 y by t. It doesn't matter to put the v0 y, plus 1/2 of the acceleration ay. Doesn't matter to put ay, is understood that is the acceleration in the y direction by t squared. And v of t is v0 plus at. v of t change according to the equation v0 plus at in a motion with constant acceleration. So these are the two equations with constant acceleration. So we plug in the numbers. Y of t equal y0, 90, initial position. V0, 80.5 by t. 1/2 at squared. 5t squared, 10 divided by 2, 5. V of t, V0, 80.5 plus 10t, sorry, minus 10t, minus 10t, minus 10t, and I hope minus 10t. No. Now the problem say when the y is 89, when y is 89, what time is at what time has happened? What time? How long a delay for the object to be on the position y 89? So you put 89 here. The y is 89, and you solve it. But this equation is wrong. Here is a minus because the acceleration is negative. This is a minus, so you solve for t. So it will be minus 5 plus 85 minus 1. This is the correct equation. So you solve for t. Now what you will do? Now what you want is the velocity when the object is at the position y equal 89, at this position. So you will use the second equation, v of t equal v0 plus 10t. And you will use this time t to find the velocity when the position is y equal 89 meters. So please work again. V plus, no, it's not plus, is minus 10t, 80.5, v of this v0, minus 10t, minus 10 by this time t, okay? And this will be a negative velocity, meaning that the velocity is pointing down, not like the 80.5. The 80.5 was going up. And this velocity, I can guess, is a little bit bigger than 80.5, but negative. The result will be maybe 83 meters per second, but negative, going downwards. So check it. You check it. Okay, and this problem is more or less the same one. Is now the acceleration is 1.62 going downwards, minus 1.62. The initial velocity v is 30 meters per second, and you launch in the moon this object, and what it says is that the initial velocity is 30, when the height is 180 meters, the time is closest. Okay, you write the equation of motion. The equation of motion is y0 plus v0y. He was on the floor at the initial time. V is positive and A is negative. So this is the equation for y of t. So when y is 100 meters, the equation will say 30t minus 1.62 divided by 2 is 0.81 t squared. So what you will do, you will solve for t. You will find the time t at what the y is 180 meters. I can see that, well, I don't know, you solve it and you see which one is the correct one. Okay, let's go to do this problem, the last one. It's say an object is dropped from rest into a pit and accelerate due to the gravity with acceleration minus 10 meters per second squared. It hits the ground, so you leave it, you drop it here with initial velocity 0. It goes this distance and arrive to the floor in 5 seconds. Okay. What it says, what is the y0? So you will write the equation. This is an equation with constant acceleration. So the equation for the y is like this: y0 plus v0 yt plus 1/2 of at squared. In this particular case, this is the y as a function of time. So the y will do like this, will decrease with time. How it will decrease? It will decrease with time it according to this equation. So the y of t will be y0, v0, y0, a is 10, so this is minus 5t squared. A is 10, so this is, sorry, I made a mistake. Minus 5d squared. So the y0 minus 5d squared is 0. When he arrived to the floor, the y0. When he arrived to the floor, the y of t, the position y is 0. So I need to find the y0 from where it was launched the body. So 0 equal y0 minus 5t squared, and this conclude that y0 is 5t squared. So y0 is 5 times the time that takes to arrive is 5 seconds, so 5 squared. So 25 by 5 is 125. So this is the depth of the pit. And now the second pit delay 10 seconds. You may think, well, if it delay 10 seconds, it means that the depth of the pit is double 125, and it's not true. Okay, now the equation will be the same one. Let me erase here. The equation will be the same one. The new depth, y prime 0, will be also 5t squared. Y prime 0 will be, again, let me erase here, 5t squared. So, but he delay 5 seconds to arrive. So the y0 will be 5 times. Now he delayed 10 seconds to arrive to the new pit. So the new y prime 0 will be 5 times the time it arrived it takes to arrive to the floor. That is 10 seconds. So it would be 5 by 100. Will be 500 meters. So the second depth, the rock delay 10 seconds in arrive, but the depth is 500 meters. Okay, this is the equation, because the equation is not linear, it's quadratic in time. That's all for the moment.